solve an equation like this, we have to do two things. One thing is off to the side, I need to know if I have any extraneous solutions. And what that means is, what is going to make the bottom 0 or undefined? So if I plugged in a 0 right here, so if x equals 0, that would be an extraneous solution and it wouldn't be possible. The next thing I need to find is a least common multiple. So I go through the bottom, I need an x, I need a 3, and this is 2 times 3 if I break it down, and I already have a 3, so I need a 2. So everything here needs a 6 and an x. So the first term, what is it missing? Well, it's missing, it has the x, so it's missing a 6, so I need a 6 top and bottom. So when I do that, I have 18 over 6x. Here, if I have a 3, it's missing a 2 and an x, so I put a 2 and an x top and bottom, so I have 2x on the top and 6x on the bottom. The last piece, I have a 6, so it's missing an x, so I have x over 6x. Now that the entire thing has the same denominator, I can drop it. So now I'm looking at 18 minus 2x equals x. If I was to draw a line, the first thing I would do is add 2x to the other side, and I have 18 equals 3x. Divide both sides by 3, and x equals 6. So before I say, is this my final answer, I check to see if it's in my extraneous solutions, and since it's not, x equals 6 is my final solution. So now we're going to continue with the same concept, but before I do that, I'm going to factor this middle one so everything's factored. So this would be x minus 2 and x minus 1. So I'm going to go ahead and start with my least common multiple this time. My least common multiple, I need at least an x minus 1. I need an x minus 2. An x minus 1, it's already on my list, and an x minus 2, and it's already on my list. So from there, I'm going to talk about my extraneous solutions. I'm going to do it for my least common multiple. If I set that equal to 0 and solve, I know that x cannot equal a positive 1. If I set that equal to 0, I know that x cannot equal 2. So if any one of my solutions are 1 and 2, then I know there's a problem. Okay, this first term. If I have an x minus 1, I'm missing an x minus 2 top and bottom. So when I do that, I have 1 times x minus 2 over x minus 1, x minus 2. Plus, the next one I'm missing nothing, so I'm going to leave it as x minus 2 and x minus 1 equals, if I have an x minus 2, I'm missing an x minus 1 top and bottom. And it's not letting me write that on the top. There we go. So I have 3 times x minus 1 over x minus 2, x minus 1. So now that my denominators are all the same, I can go ahead and drop the denominator, and I have 1 times x minus 2 plus 7 equals 3 times x minus 1. Let's go ahead and draw a line down my equal sign, and let's distribute. If I distribute a 1, I'm left with 1x minus 2 plus 7. I also have to distribute on this side, so 3 times x and 3 times negative 1. Next, I have like terms over here, so I have x plus 5 equals 3x minus 3. Now, like I said before, I'm a big fan of putting the x's on this side and my numbers on this side, so I'm going to subtract my 5 first to get rid of that, and I have x equals 3x minus 8. My next step here would be to move this over here by doing the opposite, so I have minus 3x. So let's move that up here. When I add this together, I get a negative 2x equals 8. Last step, divide both sides by negative 2, and x equals 4. Now, before I say that's my final answer, I go back and I check, and neither one of the extraneous solutions is 4. Therefore, I have my final answer.